All right, so this is just a little extra information. My company does a lot of different fires, some accidental, some arson. But one of the things I wanted to show you was what 3D imaging technology can really do for your crime scenes, your investigations, for forensic science. We talked about fire science and how fire and heat will affect materials. And what we really see that is when we go into houses and we look in places that are unburned versus burned, it's going to be pretty obvious. I wanted to show you this was a fire I did in, I believe it was Stockton. All right. And this was just on behalf of an insurance claim. And if we look, we can see that obviously this garage had significant fire damage that happened, right? If we were to look at just the other material or other areas where the fire had occurred, you can even go into here and you can see that there wasn't a lot of fire damage, right? It's just all kind of smoke staining, right? But then if we look around in this area, right? And I know there's probably a leg, but just bear with me here. We can see that there's some major fire damage, right? We use the term minor, moderate, major. And when we're trying to identify how the fire started, what we're going to do is we're going to look at the materials and we're going to look at the fire patterns. And I just wanted to show you kind of and give you a taste of what um, we do in both a crime scene and in a fire investigation. Anytime you're on a scene, it's the same and similar, I'll say it's similar methodologies. It's still that scientific method, systematic approach. It's pretty rare for an investigator to walk in and just go straight to the body, right? You have to take in the entire scene and you have to take in all the circumstances and all the blood spatter patterns, maybe even like we talked about with messages, paper, anything like that. So when we go to a fire scene, we're going to first start in the areas of least damage. Okay. And just looking at, we talk about those plastics and we talk about those, we call these light combustibles. Paper towels, if you've ever burned anything or even think about it, paper towels would pretty much be easy to ignite, right? It's a paper product, it's very flimsy, it's easy to ignite. Plastic, that would probably melt a little bit. I feel like in this corner, we can safely say that the fire did not start here. When we look at this side, it's very similar, right? We have some light combustibles, we have some shelving that are like plywood, but nothing's really significantly damaged, right? Our wooden structural members is what we call these are in pretty good shape, you know? And we go into this corner, and if we just look into this corner here, we can see that there's not a lot of damage. It has a lot more though, right? But it's not as much. We see that the cardboard actually probably took off more than other things, but we have some lighter combustibles in this corner too. But looking at the front of the garage here, we see a lot more fire damage, right? Especially in this corner. Now, what we're looking at is that charring, okay? And the char structural members, 2x4s or just wood in general, take a lot to actually take off and char, surprisingly. If you ever try to start a bonfire, it takes quite a bit to actually get it to go. You have to get kind of a initial flame that's hot enough to actually get wood to take off, especially in a house. So us looking at it, the fact that we have any kind of charring means that the structural members probably sustain a lot of heat in that one area for a longer amount of time compared to maybe over here where it has smoke, but it doesn't have a lot of heat. This has a lot of heat damage, right? And if we look, we can kind of start to make out when we talk about that V pattern. If you just look here, down below is a really, let's see if I can get closer here. Yeah, let me get a better view. Okay, so down below, there's not a lot of fire damage. And if you're like me, I'd be like, that's interesting, right? Because why would it be more damaged up here versus down here? And that's the basics of fire science. Fire travels up and out, right? And when we look at that V pattern, this is a perfect example of that V pattern. If you were to draw a line from here down, you can see a diagonal that starts to form, right? Because this is all undamaged, pretty much, right? But this side's more damaged. So when we talk about getting down in that directional, that point and arrow pattern, look at that diagonal. When we talk about that V, even the calcination and the studs on the back of the garage here are a lot more damaged compared to here. So that V pattern is significant because that tells us, okay, something came out of this area up and out because heat rises, right? And then if we look, we can see the roof sustained a lot of damage, and these wooden structural members of the garage sustain a lot of damage. We talked about that oxidation. Look at that oxidation in terms of that rusting and that warping of the metal. So when we're looking at our heat patterns and we're looking at our fire patterns, trying to figure out where the fire started, this is what we're going to use to actually look at it. And then afterwards, once you determine where the fire started, which is about right here, you can layer the debris and you can find out what is underneath this debris that are possible ignition sources that could have caused this fire. And it turned out in this area, they had a extension cord and a refrigerator and a freezer tied into one extension cord, and that pulled a lot of energy and it basically created a short in the extension cord and started the fire. But that's kind of the process. And so in forensic science, we use our knowledge of science in different ways and our experiences and the scientific method to determine what happened, because that's ultimately the goal, right? We're seeking the truth. We're trying to understand the circumstances, the situation that arose, and what happened. And this is kind of the methodology, at least at a fire scene, that you would utilize. And with a crime scene, you'll work with your investigators or law enforcement or your fire department to try to identify what happened and do a systematic approach as well. So that's just a little hint and a little taste of the forensic science realm, forensic chemistry, and fire and explosives.